Understanding the 2002 National Electrical Code Table 220.34 and its optional method is possible without external resources, but it demands a solid grasp of electrical code terminology and the ability to decipher intricate tables. The optional method detailed in Table 220.34 provides an alternative approach for calculating conductor ampacity within a raceway. This method involves a series of steps. Firstly, you must calculate the allowable ampacity of the conductors utilizing the tables found in Appendix B. Secondly, multiply the allowable ampacity obtained in the first step by the diversity factor, or DF, as specified in Section 220.34. Thirdly, determine the total number of conductors present within the raceway. Fourthly, divide the result obtained in Step 2 by the number of conductors calculated in Step 3. This division yields the ampacity per conductor. To effectively understand Table 220.34 without relying on external explanations, it is crucial to familiarize yourself with several key concepts. One is ampacity, defined as the maximum current, measured in amps, a conductor can safely carry without exceeding its temperature rating. Another is the diversity factor. This is a coefficient that acknowledges the reality that not all conductors within a raceway will simultaneously operate at their maximum load capacity. Finally, there is the raceway. This refers to any channel specifically designed to hold wires or cables, such as conduits or ducts. Once these concepts are understood, the previously mentioned steps can be applied to calculate the ampacity of conductors within a raceway using the optional method presented in Table 220.34. However, it is vital to recognize that this calculation is intricate and necessitates meticulous attention to detail. The goal is to correctly apply the diversity factor, which adjusts the overall load calculation based on the understanding that not all electrical loads operate at their maximum demand simultaneously. The diversity factor is crucial for optimizing conductor sizing and preventing overestimation of the required ampacity. Remember that the NEC provides specific guidelines for directing conductors in raceways based on the number of current carrying conductors. These directing factors are essential to prevent overheating and ensure the safe operation of the electrical system. Conductors must be selected based on their ability to handle the calculated load current while adhering to the temperature limitations specified by their insulation rating. Chapter 3 in the NEC provides requirements for wiring methods and materials, including conductor types, sizes, and insulation ratings. Table 310.15b16, now Table 310.16 in later editions, specifies the allowable ampacities of insulated conductors rated up to 2000 volts, based on their insulation type and insulation conditions. When using the optional method in Table 220.34, you must ensure that the calculated ampacity does not exceed the values specified in Table 310.16 or other relevant ampacity tables in the NEC. Pay close attention to the notes accompanying the ampacity tables, as they provide valuable information on adjustments and corrections for ambient temperature and the number of conductors in a raceway. Understanding these adjustments is critical for ensuring that the conductors are properly sized and protected. The NEC also provides requirements for overcurrent protection, such as circuit breakers and fuses, to protect conductors from overload and short-circuit conditions. The overcurrent protection devices must be selected based on the ampacity of the conductors they protect, as specified in Section 240.4 of the NEC. The NEC emphasizes the importance of proper grounding and bonding to minimize the risk of electrical shock and ensure the safe operation of electrical equipment. Chapter 250 of the NEC provides detailed requirements for grounding and bonding systems, including the sizing of grounding conductors and the methods for connecting grounding electrodes. When working with electrical systems, it is essential to follow all applicable safety precautions, including wearing appropriate personal protective equipment such as gloves and eye protection. Always de-energize electrical circuits before working on them and use lockout/tagout procedures to prevent accidental re-energization. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential to stay up to date with the latest edition of the NEC and to consult with qualified electrical professionals when designing, installing, or maintaining electrical systems. The NEC also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements may vary depending on the occupancy type and the specific electrical loads being served. It is important to understand the occupancy-specific requirements and to ensure that the electrical system is designed and installed accordingly. The NEC provides guidelines for calculating the demand loads of various types of electrical equipment, such as lighting, appliances, and motors. These demand factors are used to reduce the calculated load based on the understanding that not all equipment will operate at its maximum demand simultaneously. Accurately calculating demand loads is essential for optimizing conductor sizing and preventing overestimation of the required ampacity. The NEC addresses the installation of electrical equipment in hazardous locations, such as areas where flammable gases or vapors may be present. These locations require special wiring methods and equipment to prevent explosions and ensure the safety of personnel. The NEC also provides requirements for emergency power systems, which are designed to provide backup power in the event of a power outage. These systems typically include generators, transfer switches, and battery backup systems. The NEC is constantly evolving to reflect changes in technology and industry practices. It is important to stay informed about the latest code updates and to ensure that your electrical work complies with the current edition of the NEC. The NEC also addresses the use of renewable energy sources, such as solar photovoltaic systems and wind turbines. These systems require special wiring methods and equipment to ensure safe and reliable operation. The NEC provides guidelines for inspecting and testing electrical systems to verify that they comply with the code requirements. Regular inspections and testing are essential for identifying potential safety hazards and ensuring the continued safe operation of the electrical system. The NEC emphasizes the importance of electrical safety training for all personnel who work on electrical systems. Proper training is essential for preventing accidents and ensuring that electrical work is performed safely and correctly. The NEC also addresses the issue of arc flash hazards, which can occur when electrical equipment is energized. Arc flash hazards can cause serious injuries or fatalities. The NEC provides guidelines for assessing arc flash hazards and implementing measures to protect personnel from these hazards. It also includes requirements for labeling electrical equipment with arc flash hazard information. The NEC provides guidelines for selecting and installing surge protective devices, which are designed to protect electrical equipment from voltage surges caused by lightning or other transient events. Surge protective devices can help to prevent damage to sensitive electronic equipment and reduce the risk of electrical fires. The NEC also addresses the issue of electromagnetic interference, which can disrupt the operation of electronic equipment. The NEC provides guidelines for minimizing electromagnetic interference through proper grounding, shielding, and wiring practices. The NEC includes requirements for power quality, which refers to the characteristics of the electrical power supply, such as voltage stability and harmonic distortion. Poor power quality can damage electrical equipment and reduce its efficiency. The NEC provides guidelines for improving power quality through the use of power conditioning equipment, such as filters and voltage regulators. The NEC also addresses the issue of energy efficiency. The NEC provides guidelines for designing and installing energy-efficient lighting systems, HVAC systems, and other electrical equipment. These guidelines can help to reduce energy consumption and lower utility bills. The NEC is a valuable resource for anyone involved in the design, installation, or maintenance of electrical systems. By understanding and following the requirements of the NEC, you can help to ensure the safety and reliability of electrical systems. Remember to consult the latest edition of the NEC and to seek guidance from qualified electrical professionals when needed. The 2002 NEC Table 220.34 is very similar to the tables in later editions of the NEC, especially regarding general calculation principles. However, always refer to the specific edition adopted by the local jurisdiction. The NEC is not a design manual, but it provides minimum safety standards. Good electrical design practice often exceeds these minimum requirements. Always consider future load growth when sizing electrical systems. Oversizing conductors and equipment can provide additional capacity for future expansion. Regular maintenance and inspection are essential for ensuring the continued safe and reliable operation of electrical systems. Develop a maintenance schedule that includes periodic inspections, testing, and cleaning of electrical equipment. Keep accurate records of all electrical work performed, including inspections, testing, and repairs. These records can be valuable for troubleshooting problems and ensuring compliance with the NEC. The NEC is a complex and ever-evolving document. Continuous learning and professional development are essential for staying up to date with the latest code requirements and best practices. Consider attending electrical training courses and seminars to enhance your knowledge and skills. Obtain necessary licenses and certifications to demonstrate your competence and professionalism. Comply with all applicable federal, state, and local regulations related to electrical work. The NEC does not supersede other regulations such as building codes and environmental regulations. Coordinate your electrical work with other trades to ensure that the overall project is completed safely and efficiently. Effective communication and collaboration are essential for successful project outcomes. Prioritize safety in all aspects of electrical work. Electrical hazards can be deadly. Always follow safe work practices and use appropriate personal protective equipment. Never take shortcuts or compromise safety to save time or money. The NEC is not a substitute for sound engineering judgment. Use your knowledge and experience to make informed decisions about electrical design and installation. When in doubt, seek guidance from qualified electrical professionals. The NEC is a valuable tool for ensuring the safety and reliability of electrical systems. Use it wisely and responsibly.